start by thanking Jim Kenton and Tatiana Schubin for organizing this session, and especially Tatiana for urging me to be part of it. My goal is to convince you to think seriously about using KenKen as a possible topic for a circle, either a teacher circle or a student circle. Let's take about 2 minutes to think about two questions, two related questions. What is it about problem solving that makes it the lifeblood of mathematics? I agree that there are mathematicians, important mathematicians who build theory, but I think we all realize that problems is really what we spend a lot of our time doing. And I'd like to solicit opinions about what it is that's attractive about problem solving. And also a second related question, what kinds of problems lend themselves especially well to math circles and teacher circles? Anybody want to jump in and have a go at that?
Well, I think for your second question, problems that don't require lots of preliminary background and
right.
Technical results.
Accessible on lots of levels.
Yeah.
But on the other hand, they should be able to go somewhere and be interested.
Open-ended, kind of.
Yeah, and have some
able to go in several directions from the initial question.
Should they be easy to visualize or draw pictures of?
I think that's an important part, especially for student circles.
I feel like solving problems is the equivalent of asking questions and answering questions and getting to know somebody. It's the way you get to know mathematics in a way.
That's a good point. Well, okay, so let's begin. In case you don't know KenKen, let me explain that it's somewhat like Sudoku in the sense that the final solution is a Latin square, a collection, a matrix, an n by n matrix of numbers 1 through n with a 1, a 2, a 3, and so on in each row and each column. Now in this 4 by 4 KenKen puzzle, you can see that there are some heavily outlined cells called cages. Each cage has a clue, mathematical clue associated with it. And a clue now is a target number together with an operation. So, for example, in this cage, we're talking about trying to find two numbers whose sum is 7. Here we're trying to find three numbers whose product is 16. So, if I were doing this in a session for 7th and 8th graders, I would ask them to solve this problem and then to explain their solution to their partner. And then I would ask them to look at this collection of cages and build a KenKen problem using the alphabet 2, 4, 6, 8 instead of 1, 2, 3, 4. I would ask them to stare at this, stare at their solution, and come up with the clues and targets for those cages that would make 1, 2, 3, that would make 2, 4, 6, and 8 solutions. And eventually, someone would say, well, gee, this is just the same puzzle. And then we would be able to talk about isomorphism between two KenKen games puzzles. So you should all have a copy of this, and if you'll play with it for just a minute, I'm going to distribute another handout, and then I want to get on to another problem that I think is more elegant than this one.
Do you have any extra copies?
I think I have enough copies of this handout for everyone. There's 2 handouts that have gone out already. Let's see if I have enough of these. Up here, does everyone have a copy of this? Look for this in your handouts. It's
and I have extra pages of it here if you're missing this particular version number 4.
It's just the top 3 rows of a 6x6 KenKen. This is a puzzle I used last week at a math camp in California, and of course you never know how things are going to go when you've not presented something. But this was it was just amazing to watch a dozen kids all jumping around, pointing out different things, and eventually we had a screen, but we pushed the screen up, and so they worked just on the blackboard, filled in numbers and erased, and they just got very excited about this puzzle. I'd like to invite you now to think about this. What we're trying to do is determine a pair of candidates for the 3- gauge. So I'm going to be quiet for just a couple of minutes and let you think about this. Does everyone have a copy of this? I think we have some more copies of this show.
So I've been passing around the numbers 1 through 6 or
Yes, it's the numbers 1 through 6.